Hello students, welcome to the topic matrices. In my last video, you learned that how to find the transpose of a matrix and some properties of transpose of a matrix. Now in this video, you are going to learn a new concept on matrix, that is symmetric and skew symmetric matrix. Now let me go for a first definition of symmetric matrix. Symmetric matrix defined as a square matrix A is said to be symmetric matrix. Remember, the matrix should be square. A square matrix A is said to be symmetric matrix if A dash is equal to A, which means that when you find the transpose of A, the result is C matrix. That means we should get the C matrix. Then such type of matrix is called symmetric matrix. So another definition, a square matrix A is equal to matrix Aij is said to be symmetric matrix if Aij is equal to Aj. That means in the matrix, elements position, Ij position and Ji position, both elements are same. If position wise, if the elements are equal like this, then when you find transpose, you will get a same matrix. Okay, that means A12 position, A2 position element should be same. A23 position, A32 position. Okay, so like this, if position wise, if elements are equal, then when you find transpose, you will get a same matrix. For example, let A is equal to square matrix minus 1, 2, 3, 2, 7, 9, 3, 9, 1. Then now if I find A dash, see here minus 1, 2, 3 column wise, if I write 279 second column, 391 third column, here you can see that the A dash is same as now A only. The matrix is not changed. That means it is equal to A. So therefore what we can say here, A is a symmetric matrix. Okay, now to construct a symmetric matrix, it is very easy. Or by second definition, you can see that this is AI. If I take A12 position element, it is a 2 number, and this is A21, it is the same number, and this is A13 position and A31 position. See the elements, it is the same, and this is a A23 position, and this is A32 position 9, same number. And diagonal elements position wise, if you reverse the subscript, it is the same number. For example, 1 1 reverse means 1 1 only, it remains same, minus 1 element. A22 means if you reverse the subscript, so it is a 2 2 only, so it is the same element only, 7. So diagonal element we should not see. Non-diagonal elements you see position 1 2 2 1, they are same. 1 3 position, 3 1 position, elements are same. So in the matrix, if you take the elements like this, when you find the A dash, you will get the A matrix only. So that means here I am going to teach you how to construct yourself a matrix which is a symmetric, which become a symmetric. Okay, I hope you understood the definition of symmetric matrix. Some important point here on symmetric. If A is any symmetric matrix, then Ka, where K is any scalar, that means if A is any matrix, if you find 2A, 3A, or it may be fraction, negative, whatever matrix you find out, that is also symmetric only. There is no change in the type. Okay, if A is symmetric matrix, then Ka, where K is any scalar, is also symmetric matrix. Now the definition of skew symmetric matrix. Definition: a square matrix A is said to be skew symmetric matrix if A dash is equal to minus A. That means when you find the transpose matrix, if that matrix is equal to minus A matrix, then it is called skew symmetric matrix. So another definition: square matrix A equal to matrix Aij is said to be skew symmetric if Aij is equal to minus Aji. That means position wise elements like subscripts are reversed now, then it should be opposite of this Ij subscript. That means A12 position element, it is opposite of A21 position. Means opposite means negatively for all I and j. For example, let A is equal to 0, 2, 3, minus 2, 0, 9, minus 9, minus 3, 9, 0. Then A dash is equal to, now I am finding A dash. So 0, 2, 3, first column, minus 2, 0, minus 9, second column, and this third row elements written in third column, minus 3, 9, 0. Now this is now, it is not equal to minus A. Or directly you can take minus A, because this if we multiply it by minus sign, you will get the same matrix. Or taking negative common. Taking negative common in this A dash, you will get 0, 2, 3, minus 2, 0, 9, minus 9, minus 3, 9, 1. So this is now A matrix. So this is equal to minus A. So here what we got, A dash is equal to minus A. So now what we can say, this A matrix, this is skew symmetric matrix. Therefore A is skew symmetric matrix. Now it is very easy to construct yourself the matrix A which is become skew symmetric type. The condition is first a diagonal element should be 0. Okay, because Aij is equal to minus Aji, it is negatively equal only when if you take diagonal element 0. See here 1 1 position. Now reverse means it is 1 1 only, but it is become 0 equal to 0. So 0 we can take as an minus 0 also. Therefore 0 is equal to minus 0 we can say. Okay. Next 1 2 position, 2 1 position. Take the opposite. Like if you take this is a 2 means here you take minus 2. Here if you take negative means here you take positive number. So like this position wise if you select the elements, the matrix becomes skew symmetric type. Okay, once again I repeat, first condition diagonal element you have to take 0, and non-diagonal elements position wise you take the opposite. Okay, 1 2 position and 2 1 position, select the opposite numbers. I hope you understood a skew symmetric matrix. Remember some important point. If A is any skew symmetric matrix, then Ka, where K is any scalar, is also skew symmetric matrix. So this is also very important. That means if A is a skew symmetric type, you multiply any scalar to that like 2A, 3A, minus whatever, that is also a skew symmetric type. Now let me discuss a very important theorem on symmetric matrix. For any square matrix A, with real numbers entries, first one A plus A dash is a symmetric matrix. Remember now A is, it is not any particular type, it is just a one square matrix. Find its transpose. When you add the matrix, that addition matrix is become symmetric type. Always this is true for any matrix. If A is any square matrix, when you add with it's a transpose, so that addition, that is A plus A dash, it is always a symmetric type. And second one, A minus A dash is a skew symmetric matrix. Subtraction if we take, then that subtraction matrix is become a skew symmetric type. This is true for any square matrix. Let me prove this theorem. The first one, to prove that A plus A dash is a symmetric type, just now I defined a symmetric type. To check the symmetric type of any matrix, always we have to check its a transpose, because A dash is equal to A we should get, no? Now like that, now A plus A dash whole dash we should get same, A plus A dash. Okay, so to prove that A plus A dash is a symmetric matrix, consider A plus A dash whole dash. So that is equal to, now using the properties of transpose, if you have an addition, so individually you take the transpose, like a plus b whole dash is written as a dash plus b dash. So now here a plus a dash whole dash we have, so a dash plus a dash whole dash. Now a dash as it is, a dash whole dash by the property, it is a matrix. When you two times if you find the transpose, it remains a, it gives the same matrix. Now by commutative law we can write this as a plus a dash we can write. So here what we got, a plus a dash whole dash is equal to a plus a dash. Therefore a plus a dash is a symmetric matrix. Now in the same way we prove that a minus a dash is a skew symmetric type. That means we should get negatively equal. Now to prove that a minus a dash is a skew symmetric matrix, consider a minus a dash whole dash is equal to, now again using the subtraction rule, that is the properties of transpose, a minus b whole dash is written as a dash minus b dash, the first matrix dash minus second matrix dash, that is a dash whole dash. So a dash as it is, now this is equal to a, so therefore replace a. Now let me take negative common, so you will get a minus outside into bracket a minus a dash, which is nothing but same this term, left side term. Okay, therefore what we can say, this a minus a dash, therefore a minus a dash is a skew symmetric matrix. So very simple proof, just find out the transpose of these and get the same term, you will get the symmetric, and take the transpose of this, get the same negatively equal, then it is called as a skew symmetric. Now we have another theorem, very important theorem. For any square matrix can be expressed as symmetric and skew symmetric matrix. That means if we have any square matrix, that square matrix can be written as a sum of symmetric type matrix plus skew symmetric matrix type. Now let me see the proof of this. Let me take AB, any square matrix, then we can write A is equal to, see now A is adjusted, or A matrix is also written as 1 by 2 into bracket A plus A dash minus A dash plus A, which means here plus A dash minus A dash is added and subtracted, which means that it is 0, and plus A is taken extra, so it becomes 2A in the bracket. To eliminate that 2, outside is taken 2. That means now if you simplify this right side, it gives A only. That means A equal to A. Now right side, I take half into only for these two terms, that is A plus A dash, and next half for this second term, that is A minus A dash. Okay, see minus A dash plus A, which is nothing but A minus A dash, both are same, and half is splitted here. For this term half is taken separate, for the second term it is taken separate. Now see here, just now you studied that in previous theorem, if you have A is any square matrix, A plus A dash always gives a symmetric, and for that we have a scalar multiplication half. That means this is become symmetric matrix. And A minus A dash, you proved that it is always a skew symmetric matrix, and it is multiplied by half means it is a scalar. For any skew symmetric or symmetric, if you multiply any scalar, it remains the same type. Therefore A minus A dash half is nothing but skew symmetric matrix. So therefore A is written now, A is equivalent to half A plus A dash, means it is a symmetric matrix, plus, and this half into A minus A dash means it is a skew symmetric type matrix. That means we expressed A as symmetric matrix and skew symmetric matrix form. To write that one, symmetric matrix means you have to operate this and you have to substitute. half into a plus a dash. This one you have to operate, and skew symmetric matrix means you have to operate a half into a minus a dash matrix. So this implies a square matrix A can be expressed as symmetric and skew symmetric matrix. And remember, this part is called half into a plus a dash. It is called as a symmetric part of the given matrix A. This is symmetric part of the given A matrix, and this matrix is called half into a minus a dash, skew symmetric part of the given matrix A. That means you may get separately what is the symmetric part of the given matrix A. A matrix is given, what is its a symmetric part? That means you have to operate this half into a plus a dash. Or you may get in the examination, or what is the skew symmetric part of the given A matrix? That means you have to operate half into a minus a dash, this only. Okay, I hope you understood whatever I discussed. Note, the matrix half into a plus a dash is called symmetric part of A, and the matrix half into a minus a dash is called skew symmetric part of the matrix A. Now let me solve the examples on this concept. First example, for the matrix A is equal to 1 5 6 7, verify that A plus A dash is a symmetric matrix, and second one, A minus A dash is a skew symmetric matrix. Okay, first you write given matrix A 1 5 6 7, find out its A dash. So changing the row into column wise, now you operate A plus A dash. Now what is A plus A dash? It is a matrix plus A dash matrix. So you know the addition rule, 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5 11, 7 plus 7 is 14. So clearly we can say that this is a symmetric type, because non-diagonal element, you see we have a same number, that is 11 and 11. So you can say directly this matrix is symmetric, but by the definition we have to operate a whole dash. That means row you write column wise 2 11 and 11 14, column wise 11 14, so which gives same as A plus A dash only. So that means this A plus A dash is now symmetric matrix. In the same way, second verification, A minus A dash, find out it is a 1 A matrix minus A dash matrix. Subtracting 1 minus 1 0, 5 minus 6 minus 1, 6 minus 5 1, 7 minus 7 is 0. Now clearly this is a skew symmetric. Without finding its a transpose, we can say very easily it is a minus of A minus A dash, because A minus A dash is this. Now I am finding transpose. So 0 minus 1 column wise 1 0, second column. Now this is negative if we take common, or it is a minus of A minus A dash. If you find minus to this, if you multiply minus to this, so it is a minus of A minus A dash matrix. You will get this. So therefore directly I am writing this is minus of A minus A dash. So A minus A dash whole dash, what we are getting, it is equal to minus of A minus A dash. So this implies A minus A dash is skew symmetric matrix. So another method is just observe the position 1 2 and 2 1, they are opposite element. If these two are opposite element and diagonals are 0, therefore clearly we can say this is skew symmetric matrix. Without this operating, you can say by observing the elements of the matrix whether it is a skew symmetric or not. Diagonal should be 0, and non-diagonal elements like this position wise it should be opposite. Next example, express the matrix 1 5 6 7 as the sum of symmetric and skew symmetric matrix. Now first this is an example on second theorem. Let A is equal to 1 5 6 7, then find out the A dash. it is 1657. Okay, now you know that sum of symmetric and skew symmetric matrix means it is written as half into a plus a dash and half into a minus a dash. So first you find out these two terms. Plus first a plus a dash. First you find out a plus a dash. So a matrix and plus a dash, when you add you will get 2, 11, 11, 14. Now you find out half into a plus a dash. That means divide by 2. So if you divide by 2, you will get 1, 11 by 2, 11 by 2, 7, which is a symmetric matrix now, or symmetric part of E matrix. Now similarly, second term, that is a minus a dash, it is equal to a matrix minus a dash. Subtracting, you will get a 0, minus 1, 1, 0. Therefore half into a minus a dash means half divided by 2, this matrix. 0 divided by 2 means 0, minus 1 by 2 plus 1 by 2, 0, which is a skew symmetric matrix. So now just A is written as A is equal to, means A matrix, this 1 5 6 7 matrix, this is equivalent to sum of these two. That means you have to write only in addition form. Substitute first half into a plus a dash, that is a symmetric matrix, plus now skew symmetric matrix, that is half into a minus a dash. Now just write it in the addition form. Don't add this. If you add, you will get the same matrix. Okay, we have to express in the form of sum of symmetric and skew symmetric. Okay, we expressed here, so don't go for further simplification. That means don't add these two. So keep the answer as it is. So this is the method of writing the answer for this given example. Express means you have to express it, not simplify this addition. I hope you understood whatever I discussed in this video. Thank you, students.